Okay, OB is the vector that takes us from O to B, which you can go via C. So OC is 4, 0, and OA is the same vector as C to B is 1, 2. So if we add those together, 4, 0, and 1, 2, we get 5, 2. X is the point on OB such that OX equals KOB. So if OB is 5, 2, and X is some point along here, then OX is going to be a fraction of 5, 2. So it's going to be K times 5, 2. Or if we wanted to put that inside the brackets, it'd be 5K, 2K. AX is going to be how we get from A to O and then from O to X. So it's going to be minus of A. So if A is 1, 2, then it's going to be minus A, which is going to be minus 1, minus 2, plus OX, which we just worked out was K, 5, 2. So it'd be minus 1 plus 5K on the top, and minus 2 plus 2K on the bottom. And then X to C, we could go from X back to O and then from O to C, so it'd be minus of OX. Maybe I should write down what stages we're doing here. So this is AO plus OX. For this one, we're going to do X to O and then O to C. So O to C is 4, 0. And XO is the minus of OX, so it's going to be minus K times 5, 2. So that gives us 4 minus 5K and 0 minus 2K, which simplifies to just minus 2K. And then it says find the value of K for which AX equals XC. Well, there's AX, there's XC. We now make those equal. So we've got minus 1 plus 5K and minus 2 plus 2K equals 4 minus 5K and minus 2K. So because this is just in K, we can just equate one of the lines. So let's equate the top line. Minus 1 plus 5K equals 4 minus 5K. Add 5K to both sides, we get minus 1 plus 10K equals 4. So 10K equals 5, so K is a half. That should work for the bottom line as well. Minus 2 plus 2 times a half is minus 1, which is the same as minus 2K, so that's good, so K is a half. Use your answer to part C to show that the diagonals of parallelogram OABC bisect one another. Well, it says that AX equals XC when K is a half, so that means that AX XC. Now, if the diagonals bisect each other, then the two halves of the diagonals are the same, so we should expect that to be the same. So we've just worked out that when AX equals XC, we also know that K is a half, so X is halfway along OB. So that means that OX and XB are the same. If OX equals a half OB, therefore OX equals XB, therefore diagonals bisect. That's a very difficult question. Another way you could phrase the answer would just be to say that X is the midpoint of OB and X is the midpoint of AC. But yeah, I would say that's pretty hard, that question.